and welcome to our Game 2005 Assignment 2. And my team members are Joshua and Hayato, and consisting of myself.
So for question 1, at the installation site on the moon, acceleration due to gravity is 1.6 meter per second squared downward, and there is no air resistance. Assume the projectiles are launched from height 0, and that the ground is a uniform, flat plane at height 0. Develop a digital simulation for the motion of the package when launched. Adjust sprite, scaling, and display dimension to suit the simulation. So this is our simulation game for assignment 2. So um, first I'm gonna explain the function for this game object. So as you can see, we have the given variables here, the mass of the parcel, the launch speed, gravity, starting height, launch angle, airtime, and the parcel range. So, and I set this to public float, and also I set the numbers to 0 um, so that the player can change for what numbers they want here. Yeah, and it looks clean. So in the start method, I set the um, parcel I set the parcel starting height using this function, and in the fix update, actually I got this idea from the labs, and if the space bar is pressed, it calls the method to initiate this function, and if the parcel has been launched, it will call this method. So in the launch function, here I I convert these variables to regions to so that to calculate the launch speed and angle for the parcel, and I set the parcel velocity to these variables, and I set the public float launch to true, airtime to 0, launch position to position, and the bool parcel landed to false. Um, so the last function, this part, it updates um, the updates the parcel position by adding the velocity, and I multiplied it by the time fixed delta time. So in the if statement, so if the parcel position y is less than to -1, so I'm gonna show you this. Yeah. So, and also if the parcel is not true, so if the statement is true, it will call this. Wait, actually we don't need this. Wait. Yeah, I think we don't need this. Hold on a second. My bad. I'm gonna try this. If it works. For some nothing. So I'm gonna try if this works. Let's say 10, 1.6. Yeah, it worked. This is all for the question 1. So for question 2, I'm gonna test each angles using our simulation to know the range and the flight duration of the package. So first I'm gonna test the angle 0. So let's set this to 0. So the airtime of the package is 0.02 seconds, and the distance traveled is 2.4 meters. Let's test the angle on 3.19. So the airtime for this is 8.3 seconds, and the distance traveled is 1001 meters. So next is 6.24. The airtime for this is 16 seconds, and the distance traveled is 1944. Let's test this angle 9.736. So the airtime of the package is 25 seconds, and the distance traveled is 2,999. This is the launch angle of 13.194. So the airtime for this is 34 seconds, and distance travel is 3,998. This is the launch angle of 16.8 874. So the airtime is 43 seconds, and distance travel is 4,199. This is the launch angle of 20.905. The airtime for this is 53 seconds, and distance travel is 6,001. This is the launch angle of 25.592. So the airtime for this is 64 seconds, and the distance traveled is 7,010. This is the launch angle of 31.367. So the airtime is 78 seconds. And the distance traveled is 7,998. This is the launch angle of 45 degree. So the air time for angle 45 is 106, and the distance traveled is 8,999. So this is the launch angle of 58.6633. So the air time for this is 128, and distance traveled is 7,998. This is the launch angle of 64.471. So the air time for this is 135, and the distance traveled is 7,011. This is the launch angle of 69.095. So the airtime for this is 140. And distance travel is 6,000. This is the launch angle of 73.126. The airtime for this is 143. And distance travel is 4,999. This is the launch angle of 76.806. The airtime for this is 146. And the distance traveled is 4,000. This is the launch angle of 80.264. The airtime for this is 147. And the distance travel is 3,000. This is the launch angle of 83.58. The airtime for this is 149 seconds. And the distance travel is 2,000 meters. This is the launch angle of 86.81. So the airtime for this is 149. So if we run off this is 150. And the distance travel is 1001. And this is the launch angle of 90 degree. So the airtime for this is approximately is 150, I think. And distance travel is 0. And this is all the results for each launch angle. And that's all for question 2.
So for question 3, we're asked if the experimental results differ from the mathematical analysis of assignment 1. And this is my analysis of comparison for assignment 1 and assignment 2, the mathematical analysis and the experimental results which I got. So yes, they do differ, but however, the numerical precision is correct, because in my assumption, I thought the numerical values would be around this range for both the mathematical and the experimental values. It's due because if we were to perform this experiment in real time and we went physically to the moon and performed this experiment, our ranges would be the same for all these launch angles that we have over here. And that's only due to when we perform this experimental results in Unity, and that's built as a default in the Unity physics engine, because in code we're using time.delta time, which has a set time to 0.02 seconds. However, real time is not set to that time. So when time.delta time is set to 0.02 per frame, it will reduce the range because in the formula, because we're having a 0.02 second error in the code. So when I set the launch angle to 58.83 degrees, my console will give me the distance traveled for the parcel, which will result in 7,971.118 meters. And that's due to set as a default for the Unity physics. However, if I were to do this experiment in real time, our range would be 80,000 meters, and that's because we're doing it in real time, not in delta time, which is set to 0.02 seconds. And that is it for my assignment 2. Thank you for watching.